you have to know what is a network. We have already you have already studied what is a network, right? How the nodes are going to be interconnected through the help of your network, right? And we have defined studied what are the criteria of how will we measure the performance of a network, right? These are the points that you have already discussed. And you have to know the types of networks. So types of networks you have, right? So we have different types of networks. So when we say networks, how this uh, so types of networks. So we know the different types of networks. So you have heard of the word we have LAN, right? Second we have WAN, we have this one. So you already have some idea what is a LAN, what is a WAN, and what is a MAN. Alright, so I'll not go much in details. This is a very easy topic only that you can study by yourself. Alright, so I'll just read just once what is a LAN, what is a WAN, and what is a MAN. Right, so this is LAN is called as this is should be in capital, okay? LAN. It is nothing but a local area network. Okay, it is a local area network. Alright. So now you see, as I told you, that with the help of the networks, with the help of your network, your computers are going to be connected and communicate, right, with different computers via a medium, right, via a medium that is going to be connected. So if it's one computer is here, and another computer is here, it can communicate through a medium, right, through a medium. So what are the mediums here? Actually, how it is going to be communicate? It can to be communicate with the help of local area network. It can be connected with the help of a wide area network, and it connected with the LAN. All right. So the first one is the LAN. So what basically is this? And even we have this one PAN also. This is personal area network. All right. So the first one is called as a local area networks. Okay. So here, this type of connected, see, this type of communication is within your, suppose it is within your, the range, okay. Locally, it is going to be connected. Locally, it is going to be connected, okay. So it is very simple one where you have you're building this one from, suppose you're from, have to do it like this. It's just loading. So I don't want any more disturbances. Fine. Okay, let me this one. Okay, so let us do this one. LAN, 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 LAN. All right. So this type of when we compare this, okay, how we're going to compare. So this type of local area network. So this type of network covers, okay. So this type of network covers a small area like it that is like it that is within the building. So this type of when we have this LAN connections, it can cover the area that it cover. It should be within the building. Alright, so within the building. But in case of wide area network, in case of area network, it covers, it covers, this WAN, WAN. Okay, this is nothing but wide area network. So wide area network, it provides long distance transmission of your data and voice. All right. So what type the area that it covers? Okay, the area that covers, that means it covers a larger. That is why it is named as wide. But in the case of local, it has to be connected within a local area or within a campus or within a building. All right, that is why it is named as the local area network. And wide area, so it is for long distance transmission of for your transmission of your data or voice. Got it? So when we talk about the area covered by the WAN, it will be what? It will be a larger area, such as, for example, such as a city or a state or a country or the world. All right, or the world. It is known as your wide area network. And the last one, that is your main. Main is nothing but metropolitan area network. Metropolitan area network. So metropolitan area network. See, this metropolitan area network is, it is larger. It is larger than, it is like this, LAN, MAN, and WAN. I hope you can see, right? So this metropolitan area network can cover. Okay, it is only, this is larger than your LAN, but it is limited to a, but smaller than your, than your WAN. So how will you say? And while larger than LAN is LAN, they are easy to design. They are, and maintenance is very not very expensive as compared to your WAN, right? Like that you
Ma'am, your
can give,
screen is not visible.
not visible. Okay, fine, fine. now you can see, right? So you can say that you can write many points to differentiate between local area network and wide area networks. You can write difference between main and when also you can write, right? So these are the whole this one. And so, and when you the point like what is the transmission medium? Okay, transmission medium means what is the transmission medium of land? You can say this is a coaxial cable. That means the transmission medium, the one you're using now in your lab and all, we have a land where, right? They are actually made of coaxial cables. They are called as the coaxial cables. The wire that you're using, okay? So what is the transmission medium of land? You can say it is a coaxial cables. What is the transmission medium of WAN? You can say is this one satellite link. All right, like that you can give. So these are very and you can use PSTN, right? PSTN. So we will move to the very important one that is called as a topology. Okay. The next one is a very important one that we will be concentrating, that is known as the topologies. So what we have studied what is a node, right? So we have already understand what is a nodes. Node is nothing but your devices, right? So we know what is a medium. Medium means the transmission medium, right? Transmission mediums and how these are going to be connected. How from one device to another device it can be communicated through the help of your medium, right? Then next is topology. What exactly is a topology is all about? So as we already discussed about what is a network, right? We already discussed what is a node, what is the medium, what is a network. We already know that these three terms, right? The next one is how uh, how we are going to arrange the networks. Okay, how we are going to connect, how we are going to connect the networks. All right, that is actually known as your topology. All right, so topology is also defined as the layout of connected devices on a network. That means how your devices are going to be connected with the help of a network. That is called as your topology. So you can see different definitions about the topologies, but the internal meanings is same only. All right, the internal meaning is same. So let's understand the different type of topology. What are the different type of topologies and all? All right. So we understand that means what is a topology? It is the layout of connected devices. Okay, layout of a connected devices, or you can seek, you can call as the arrangement of a network, the arrangement of a network. So how we are going to arrange the network in such a way that you know that all the nodes, that means the nodes that your device can be communicated. All right. How so? How this? So you have a device here. So how? So you have a device one here and device another here. All right. So how these two devices are going to be connected? So it has to be connected with the help of a network. All right. So but the question is how you are going to arrange that? How you are going to connect it? Whether you are going to connect it with the help of this one. So how it is the arrangement? Okay, the arrangement of a network to connect these two devices known as your topology. All right. So you can refer any definitions about topology is, but the internal meaning is same only. Internal meaning is same. All right. So these are called as your topology. So that means I'm going to explain you once again. Okay. Topology means how your computers, how your computer here, right? This is also a computer. This is one devices, right? How the computers, your cables, or your other components within a within a data communication network are going to be interconnected, both physically as well as logically. All right. That means if we have a device here, if we have a device here, if we have a device here, how these devices are going to be, this is within the network. Yeah, this is within the network. How these are going to be interconnected. All right. Both logically, both logically or physically. All right. So that is called um, actually called as your topology. All right. So physically, by physical topology means physical topology describes how the network is actually laid out, and logical topology describes how the data actually flow through the network. Got it? So this how we are going to arrange the network, one physically and one is logically. Physically means how your network are going to be arranged, how we are going to arrange it, and logically means how your data can be, how the data actually flow through the network. All right. So the most, the two basic, or you can call as the basic topologies are, two basic topologies. Topologies. What are the two basic topologies are? Number one is your point to point, and the second one is your multi-point. So there are two basic topology. What is that? Point to point and multi-point. So a point to point topology usually connects two mainframe computers. Connects two mainframe computers for what? For high speed digital information. What about a multi-point? It connects three or more stations through a single transmission medium. Okay, point to point from one C, point to point, multi-point. Three or more stations are going to be connected, right? Going to connect it. So point to point means from one point to another one, right? Point to point connection. What about this multi-point means how this topology will help to connect more than three or more stations through a single medium. I have using only this one. It is going to be connected. So I can refer like this also. This is one medium where I have connected three stations, or I can connect four stations also, five stations also, like that. All right, through a only one single medium. That is called as a multi-point. Now, example of multi-point is like your bus. Okay, we will study about different type of bus, star, can NAS and hybrid. So we will be focusing more on multi-point topology. All right, multi-point topology. That means when a devices, when more than 2 to 3 stations are going to be connected. Okay, that is called as a multi-point. All right, multi-point. So you understand what is a point to point? Point to point means from one to another. That's all. All right. So if we have only two devices, two mainframe computers, why these two mainframe? For interconnection. We use this point to point. Why this point to point? Two, for high speed digital transmission, right? High speed digital transmission. Now, if we have more than 3, 4 computer stations, station means your devices. Okay, if we have 3, 4 stations are there, how we are going to do that? we are going to use this multi-point topology. Multi-point topology. All right, multi-point topologies, they are going to, these four devices are going to share a single medium. Let's share a single medium. A single medium. These four devices are going to be what? They are going to share single medium. So I can use like this. Suppose this is my transmission medium, right? So I have drawn only one single line, but now we have four devices, right? Four devices are here. Four devices. These four devices are connected to a single medium. Now, if suppose this is A and this is B, C and D. Suppose if I want to make a transmission from A to B, I can use this transmission, right? I can use this medium to transfer the data from A to B, right? And from B, from it can receive like that. This is just a simple examples of multi-point. That means stations. I have four stations here. These four stations share a single transmission medium is called as the multi-point topology. So what are the types of multi-point topology that we are going to discuss? The first topology is called as your bus topology. BUS bus topology. See, I'm not going to give any notes, okay, but you have to note it down the topics that we have discussed. All right, that we have discussed. So it will be important. It will be benefit. At the time of examination, ये नहीं पूछना है कि what are the topics that we have discussed and all. You cannot ask. All right. So the first topology is called as your bus topology. So this bus topology, what actually is? So this is a network, a type of network, right? It is a type of network for this in which every computer, that means every computer here, say I'll draw like this. Let me draw three stations. All right. Okay, I'll take one more. So this is node 1, node 2, node 3 and node 4. How many devices are connected? 4, right? We have connected 4 devices. Am I audible to you? Please reply.
Yes, ma'am.
Ma'am, you are audible, but actually your voice is breaking in between.
Right?
Like your network is not stable.
Not stable. It's what actually happening. Now it's fine.
Yeah, now it's better.
Okay, fine, fine. If you have any this one, you raise your questions. Okay, raise means you can tell me whether you can see, you can hear or not. You just inform me. So you can see, I have taken 4 devices, 4 nodes or 4 stations. Fine. So what does this the bus topology is means? It's a network. It's a type of network. All right, in which every computer, every nodes. All right, every computer and network devices is going to be connected to a single cable. Got it? It has to, this network as well as your network devices, your computer are going to be connected to a single cable. So this, all right. So let me tell this. This is a coaxial cable, or you can call as a transmission medium. Transmission medium. All right. So all the devices are going to be connected. The devices are going to be connected to a single cable. Right. Now, what is the next point? That means the next point is it transmits the data from one end to the another in a single direction. So, what is the next point? Transmit the data from one point to another in a single direction only. In a single direction. Alright? That means no bidirectional is allowed. Bidirectional feature is in bus topology. No bidirectional, only single direction. It is also called as a, this topology is also called as a multi-point connection. Why? And one more thing is that one more point is that it is a non-robust topology. Because why it is a non-robust? Robust means what? Robust means suppose if your system fails, how it easily recover. That is called as a robust. But here it is a non-robust topology. Why it is called as a non-robust topology? You can see because this is your backbone of your backbone of the four devices, right? Suppose if this break, if this fails, what will happen? Your topology crash. Your network will fail, right? This actually is the topology. Now, if this is fail, if this one is fail, it has no effect on your transmission of your data, right? I can transfer from node 3 to node 2 or node 2 to node 4. But if your transmission medium is fail, because this is the lifeline of all the nodes here. So if this is the backbone of your network. So if this fails, that means your topology crashes. Got it? Your topology crashes. Got it? So that is why it is called as a bus topology. So all the devices. So how will you write? How will you write? So bus topology. It is a multi-point topology, right? It is a multi-point topology. That means a long cable is going to. So you can write it in your own words also. It is a multi-point, right? Multi-point topology. Number two, you can say that a single transmission medium or transmission you can call it a long cable, but it should be a single one. Okay, long cable will act as a backbone to link all the to link to link all the devices that are connected to that particular cables, right? That is called as your. And number third point is that this type of topology allow only one device to transmit at a time. To transmit at a time. Got it? That is why it is called. It is not a bidirectional. Not a bidirectional. That I already told you. That means only one devices can be transferred at a time. Got it? So I have already draw the topology figures also. Right. What about this? I can draw one more thing. So you can take one more example, like suppose you have a device like this, right? So how will you going to be connected? So we can connect like this. I can drop it down like this. I can move it like this. You can see now. You can see that all the devices are connected through a medium, and it and what is the next third point? That means only one device can be transmit at a time. So if it is transmitting, so suppose if it is transmitting and it wants to send to data here, suppose this is your sender and this is the receiver, all right, and so it is going to be, so it can going to be transmit, so it can transmit only, so sender S can be transmit. Suppose this one also wants to transmit, suppose to here or here. Okay, let me take this one. S is the first one to be transmitted. Okay, so B has to wait because they are using only a single transmission line. So and in the bus topology it says that it can be transmit. So when one device is transmitting, another has to wait. All right. So this is just simple topology. Next is a important one is called as a mesh topology. All right, mesh topology. Anyone who had joined? Nobody know. So, what are the advantages on a So the advantages of bus topology are the very easy to install, right? And a very easy to install, very easy, as well as the cost of a cable is also less, right? Cost of cable is less. And what is the disadvantages? Disadvantages. If we speak about the disadvantages, uh, you know, you know, you can say uh, your single transmission fail. Then if your this one fails, your whole transmission is going to be fail, right? Then means if your medium is fail, then your whole system is going to be fail. And if your network traffic is heavy, if the network traffic is heavy, network traffic, right? Traffic is heavy, what will happen? It increase collision in the network. So in order to avoid this, various protocols which are used in your MAC layers and all that we will study that you have heard of this secure along
Ma'am, your voice is breaking. Can you repeat?
alright, so security is very low. So these are the disadvantages. Problem with this topology is that there is if the common cable fails, then the whole system crash, right? Then this one, if your network traffic is heavy, then it might there is a increase in collision in the network. This is the second point. Security is very low. These are the disadvantages. Okay, so we'll move. You can see the book also. What are the different disadvantages and all in detail. Next is called as the mesh topology. Mesh topology. So by the name itself, mesh topology. All right. So let me show this. Suppose I have a five devices here. So in mesh topology, that every device. So I have a device here, one, two, three, four, and five. All right. So in this mesh topology, every device is going to be connected to one another via a particular channel. It is going to be connected via a particular channel. So how will we connect? So that means every devices. Suppose if I want to connect with one to two, so I will use a particular channel for this, a medium. If I want to connect with this one to four, I can use another particular channel like this. Suppose this one also. Are you getting my point? So this mesh topology here, mesh topology means every device is going to be connected to another devices via a particular channel by using their own channels. All right, that is called as your mesh topology. Got it? This is called as your mesh topology. If my voice is breaking, you please tell me, okay? So that means you can see that every device are going to communicate connected with the help of a particular channel. What a particular channel means? That means every devices from 1 to 2 or 1 to 3 or 1 to 4 or 1 to 5, every devices has a point-to-point link. Yes, every devices has point-to-point, point-to-point link to every other devices, right? Every has a point-to-point, right? That point-to-point link to every other device. And one more thing is that so this one is a little bit lengthy, so I'll go through this. So first point was point-to-point, and the second point is every device is connected. I'm going to write this point, okay? Connected with another via dedicated, or you can write as the point-to-point channels or point-to-point connections. Okay, and this point-to-point channels or point-to-point they are called lines, or they are called as your links. Yeah, this channels is called as your links. We are going to use the term called as links. All right, we are going to use the term called as your links. And coming back to this, you can see that if suppose, if suppose n number of devices, suppose here we have only 5 devices, right? If there are n number of devices are connected with each other, suppose if there are n number of devices is connected to each other in a mesh topology. Suppose if we have a n number of devices and you want to connect through mesh topology, then the total number of ports required by, the total number of ports required by each devices is n minus 1. So if we have n devices, and if the total number of ports that required by each devices will be n minus 1. For example, like I have taken 5 devices, right? That the number of here n is nothing, n here is here. According to our example, the number of n is 5, right? So we have 5 devices which are connected to each other. Hence, the total number of ports, the total number of ports required by each devices will be 4. Therefore, the total number of ports required is equal to n into n minus 1. So this is a formula that you have to know. So in the exams, they are going to ask a question can comes arise from this one also. Problems, you have to know this formula. All right, you have to know this formula. Suppose, and again, if suppose n number of devices are connected with each other, okay, n number of devices are connected in a mesh topology, then the total number of dedicated links to connect them is given by NC of 2. That is given by n of n minus 1 divided by 2. So you have to learn these two formulas. The total number of finding the number of ports, and the total number of finding the dedicated links. So this is the formula. All right. So according to the examples, n was 5, right? N was 5. If we have to find the number of dedicated links, will be 5 into 4 divided by 2. So it will be around, what is that? 20 by 10. We will get 10. We get 10 links, right? We get 10 dedicated links are required, right? We require 10 dedicated links to connect the 5 devices. And the number of ports will be 4, and the number of dedicated links, that means the link, as I already explained, no? So this is the link, right? So number of links required will be 10. So this is called as a mesh topology. So what is the advantages? Advantages is robust. Advantages is robust. Robust means suppose if if your network fails, how it easily recover from the error. Okay, how it easily able to recover. That is called as a robustness. And here fault is diagnosed easily. Why it is called diagnosed easily? Suppose if you have a problem in this one, in this device number 2, you can easily identify in which node you have an error, right? It is easily to identify. That is why it is called. um, and the third one is it provides security and privacy also. All right, these are the third points. And what is the problem with the problem with this? And one more questions I want to ask you. Suppose if there is a problem with this particular link, does it going to affect the whole system? Not at all, right? Because every node has its own dedicated link. So failure of this link does not going to affect the whole system. Only this particular devices cannot transmit because this link is got an error. All right, so this is the this one advantages of between this one mesh topology. But as we already studied in bus topology, they have a common medium, right? They have a common medium. So if your link is failed, your whole network, your whole system will crash. That is the difference. All right. So this is the advantages. Advantages is dedicated link is required, and then so traffic problem is also can be avoided. But in the case of bus topology, if there is a heavy traffic is there, collision of networks will take place, right? But in the case of network topology, mesh topology, as they have their own dedicated links, so the traffic problems can be avoided. Problem is avoided, and uh, and it is also I already told you it has robust. That means if any link got damaged, it cannot affect others. It cannot affect others. So if link 2 is affected, so it does not affect on the third, fourth, and fifth. So and then provide security and privacy, right? Security and privacy means that message travels along a dedicated link only. Suppose if I want to send a message to from 2 to 3, 4 to 3 or 3 to 4, I'm using a dedicated link between this. I have not used any other devices not connected to this link. So the security is high. Security is high. So the message only travel through a dedicated link. That's why the privacy and security is high in mesh topology. And then fall identification is also fall identification. Suppose if your device 2 is not working, we can easily identify. Okay, so this is the advantages. Now coming back to your this one disadvantages. So disadvantages, what could be the disadvantages? So the number of cables is very high. The number of cabling is very high, right? And the number of I/O ports is also number of cables as well as number of I/O ports are required very large. Are required, right? Are required in large quantity, right? In large quantity, and the cable also, right? Number of ports as well as the number of cables are required in a large quantity because we need a dedicated link between each devices. That's why your cables are you require large number of cables. Large number of cables means you need to spend more amount to buy the cables, right? So that is the disadvantages. And the hardware required to connect it each device is highly expensive. All right. So the hardware that we are going to use to connect each device is highly expensive. So these are the disadvantages. Now you can give an example like applications like your telephone regional office example. WAN is also a example of your mesh topology. All right. Telephone regional office. So these are the applications where your mesh topology is used. Got it. Next is called as we will go for one more topology and we will stop here. Okay. So the last one is your star topology. Last topic for today. All right. So the star topology. Now in star topology. So what exactly is the star topology is? So by the name itself, you already have got some idea what is the star topology is. Right. So a star topology, how does a star topology look like? Suppose you have you have it here, and then these are your computers. All right. So you can see that in a star topology, all the devices, suppose one, two, three, four, right? All the devices are connected to a single hub. through a cable. So this is actually a hub. All right. So you will learn what is a hub, what is a switch, what is the router, and all in the coming up process. All right. So this all the devices are connected through a common hub, to a single hub through the cables. They have their own dedicated this one, but these are all connected through this hub. All right. So this hub is actually the central node. It acts as a central node. It is going to act as a central node, and all other nodes are connected to the central node only. Okay. Got it? So here you can see that where each device has a dedicated point-to-point link to the central node only. Okay. So hub is actually act as a exchange. Okay, exchange. Now, next point, what is the star topology? There is no direct traffic between the devices. There is no direct traffic between the devices. That means traffic problem is also solved, right? And the transmission are occur only through your central nodes only. So if I want to transfer from 1 to 3 or 2 to 3 or 2 to 4 or whatever, it can be done through the help of your hub on. That means if I want to transfer from 2 to 3, first it has to, when the message says, so suppose if you want to transfer a message from 2, it will go to your central node, and then from nodes it will reach to your destination. That's why the transmission are occurred only through the central node. When and one the last point is when device say 1 wants to send a send a data to 2, what will happen? First, this data will send to your central hub, which then relays the data to the other connected devices. That means that this is what I've seen. So if I want to send a data from 1 to 2, first it will reach to a central hub, and then only from hub to the connected device. That means to the destination. That is called as the star topology. All right. What is the advantages? Advantages is that they are very less expensive comparing to your mesh topology, since every device is connected to a central node only. Okay. And then the second point is installation and configurations are very easy. Number third is less cabling is required. Less cabling is required than mesh. Even though they have a dedicated link, they have a less cabling as compared to your mesh topology. All right. And robustness. Robustness means link failure, right? Suppose if one link fails, only that link is affected. Suppose if your link, this one is fails, only this link is going to be affected. The rest of the system will not fail. The rest of the link will remain active. There is no change in the systems. And uh, easy to easy to find the fault part. That means if node 4 is having a problem, we can easily identify and remove those parts. All right. So this is the advantages. Now coming about disadvantages. Disadvantages means even it requires less cabling than mesh when compared to other tablet, it's still large. Yes or no? Yes. Even though you have a less cabling is required. Less cabling is required. Less cabling than your mesh. Right. Even it required less cabling than mesh when compared with other topology, it is still large. So when we compare your star topology with the bus topology, the number of cable is still large, right? Still large. So this is one disadvantages. And then dependency. Dependency is one thing. That means the whole network. That means your whole devices is dependent on your central hub. Right. So if your central hub has a problem, so if your hub or central node goes down, what will happen? This whole system is dead. That means whole system is all the devices are dependent on your central node. So if your central node has a problem or goes down, the whole system is going to what? Fail. It is going to be fail. So this is the example of your this is the disadvantages of star topology. And what are the application of a star topology? Where this star topology can be used? It can be used in your high speed. The star topology you have used of LAN. So in this we use this star topology. Alright, in local area network. So these are the examples. Applications they can ask you where the star topology can be used. You can give an example. LAN. And what about MAN? About WAN? For WAN, it is mesh topology, right? So you can give the difference in this one, the difference like this. All right. So today I'll stop here. From next tomorrow also I'll take class. Okay. And please leave your attendance in your this one in the this one the WhatsApp group. Give your enrollment, just the enrollment number. Okay. So see you tomorrow.
Ma'am, excuse me, ma'am.